Okay, this is a lesson on Sohcahtoa and the basics of Sohcahtoa. So, we use Sohcahtoa to find lengths of triangles or to find angles in triangles. For this tutorial, we will only be looking at finding particular sides of triangles. So here is my right-angled triangle. You know that this angle here is 50 degrees, and you know that this side here is 25 meters. I keep saying the word Sohcahtoa because it is an abbreviated version of these three triangles. This triangle here is telling you this, that the sine of an angle equals the opposite side over the hypotenuse side. That's this triangle here. This triangle here is telling you that the cosine of an angle equals the adjacent over the hypotenuse. And this last triangle is tan of an angle equals the opposite over the adjacent. Sine, cosine, tan, they are all technically ratios between sides of a right-angled triangle. So when a triangle has this particular angle, the relationship between this line, the hypotenuse, and this line, the adjacent, the relationship between those two, the ratio between those two, is always going to be the same, no matter whether the sides are this long or whether they're longer. The ratios are going to be the same. Your calculator magically, well, not magically, it's been computer programmed to remember these ratios. So I can press in sine of 50 and it will give me a particular number. That's the ratio between sides for sine of 50. I can type in cosine of 50 and it will give me a different ratio. Don't worry about that too much, because here is how you technically go about solving such a problem using Sohcahtoa. First step, label the sides. So this side here is the hypotenuse, it's the longest side. This side here is right next to the angle, so it's the adjacent. This side here is the opposite, because it's opposite the angle. Now, I haven't written in an X. I should have done. I would like to know this particular side. The next step is choose your triangle. That is, you look for the sides that you care about and then use the particular function that goes with those two sides. So, in this particular example, I have the hypotenuse that I care about and I have the opposite that I care about. For this example, I'm not worried about the adjacent. I don't need to know that side just now. The triangle that has both the opposite in it and the hypotenuse in it is your SOH triangle. That is, sine of the angle equals the opposite over the hypotenuse. So we choose this particular triangle here, which is going to be this particular equation. We don't care about the adjacent, so we're not interested in the car triangle, and we are not interested, again, in the adjacent over here, so tan is out of the question. Toa is out of the question. Step 3, we write this equation. Sine of angle equals opposite over hypotenuse. In this particular case, to find the opposite, we multiply these two together. So sine of 50 degrees times by 25 meters is going to give us our opposite. The two bottom numbers on the triangle we multiply together to get the top one. In this particular case, so I type it into my calculator, sine of 50 times 25 equals 19.15. X equals 19.15. I know this all sounds really complicated. In the next video, I will give you another example, and another example, and another example. After a while, you will get the hang of it. Just keep practicing different examples. If your teacher is a different teacher than to me, you do it the way your teacher has taught you. Okay?